Okay, so here we are at subtraction, and for me, this is kind of the hardest one to teach, and it sort of takes a bit of time to understand and a couple kind of run-throughs with it, even harder than multiplication and division, which is sort of strange. But this is, oops, another compensation strategy, but it's got a bit of a twist. It's a little different than the addition one. In fact, it's sort of the opposite, which makes sense since addition and subtraction are opposites. And it works on the idea of a constant difference. So when we were compensating for addition, we were trying to keep the end the same. We were trying to keep the sum the same. And that made sense because we were putting them together. In this case, we're looking to keep the difference, so the change, the same. I'll give you a really sort of simple example, sort of 9 take away 6. So we can imagine these on a number line going from 0 to 10. And here we are, so there's 5 in the middle. And we're at, 6 is here, 9 is here, and that difference we know is 3. I mean, that's a question we know. So that's called the difference, the sort of the space in between, the amount of number in between those is 3 wholes. That's the difference. So if we wanted to change one of these numbers, and let's change the 9 to a 10. So if we wanted to change those numbers, I'll put 5 in there again, then we're moving the 9 over 1. So we're adding 1 to make it a 10. And you can see it jumping right there to the 10. So now we're here instead of at the 9. And we want to keep that difference the same. So we were at 6, and the difference was 3. But if I did that now, the difference would be 4. That's too much. So I need to move the 6 over to 7. So I'm actually adding 1 as well. And now I can see that difference is still a change of 3, a difference of 3 whole numbers. So that's the idea of constant difference. And so it's the opposite of compensation for addition. If you go back and look at that video, if you don't remember, where if we added 1, we'd have to subtract 1. Or if we added 1 here, we'd subtract 1 here. It was always the opposite what we did to those two add-ins. Here, it's different, and it makes sense now if you think of that constant difference. Kind of a tricky thought. I mean, subtraction is kind of a different cat. So let's look at much larger numbers, but much more sort of useful numbers for grade 5 and 6. Let's take a question like, 361 take away 198. So, much larger numbers. So putting these in the number line would be a lot of work. So let's not do it yet. But you can probably see what I'm thinking, and that this is really close to 200. And that is, in fact, what we're going to do. We always want to change the second number. And if you think of it, when I was in grade 5 or 6, stacking these numbers up like this, and then all of a sudden I can see, before I even start, oh man, I'm going to be doing a lot of borrowing or carrying or whatever, it's regrouping, whatever you want to call it. Because, I've got 1 take away 8, I got 6 take away 9, which again is not 6 and 9, 60, 90. But so there's going to be a lot going on here. I can already see that. And same here, even just looking at this, it's difficult. But if I change this to have a bunch of zeros, which it does now if I make it 200, so that's sort of my wish. I wish this was 200, because taking away zeros is easy. So I'm changing it. So I'm adding 2 in this case to get it up to that 200. And I'm going to do the same to my 361. And it's going to become 363. And I mean, you can just see how easy that's going to be. If I go back in time, which would be amazing, and I turn this into one of my questions that I did a million of, I mean, easy money, right? And then just looking at it, I can see, that while there's 63 and then there's an extra 100, and I can see the answer right there. I mean, if it still helps you to stack them up, you could. And so that makes sense. I can see that now on my sort of number line here. And we'll go from 0 to 400, since we're right around there. And then here's 200, and there's 300, and 100. And so originally my numbers were, I was like right around here. So, I was at 361. And my other number was, just behind the 200 at 198. So there was my jump. And we didn't know what it was. I mean, it turns out it was 163, but I certainly didn't know that when I started. And instead I've changed it. All right, so again, I'm going from 400, and there's my 200 and my 300. I'm purposely jumping that one up. That 198 I added 2. So I'm purposely changing it to that position, that 200, which made it a lot easier for me to subtract. And so you can imagine that 361 had to go up as well to 363. And that way I kept that constant difference, which we still didn't know what it was, but we found out was 163. So I hope that video is somewhat useful. I mean, it's a very sort of tricky concept to get. Understanding subtraction in general is a little weird when you get into numbers this large. But if you try that out a few times and maybe draw the number line to help you as well, you'll see how this compensation can be very handy. And it's all about changing that second number to be something useful. I mean, sometimes it doesn't work so well where you get a nice round number like 200, but even if you just can change that that one spot and turn it into a 0, it helps a lot. So the more zeros you can get in the number, the easier it is to subtract. And if you're not good at kind of seeing that that's 163, well, then stack them up. But at least it's very easy, and there's a lot less chances to make a mistake when you're subtracting, zeros from things compared to, you got to make this an 11, you got to take this, take 1, which is really 10 from here, and then, it gets very complicated. So I hope that's useful. Try it out a couple, and we'll see how it goes.